This is how the cockpit or flight deck of a jet airliner works. Some systems described here can be even better understood by watching our companion video, How an Airliner Works. This is a flight deck, which implies a bigger space with room to move or walk around, as opposed to a cockpit with just enough space for seats that pilots might climb into. Starting at the back wall of the flight deck, there are hat clips and the pilot's wardrobe closet. On the other side, there's a jump seat that slides and folds out. There's a crash axe nearby, as well as a flashlight, oxygen cylinder, and portable breathing equipment. Detailed circuit breaker panels are situated near the back wall on both sides. Seating. The pilot and co-pilot seats move back and to the side for entry. They have a 5-point harness and ample adjustments for proper access to flight controls, as well as comfort. There are heated foot mats in the floor. Eye level locators between the front windshields indicate proper seat position, ensuring optimal visibility for all flight deck operations. The ideal position is reached when the white sphere is completely hidden behind the front red sphere, as viewed by the person adjusting the seat. The armrest on the outside of each seat has tilt and vertical adjustment knobs for unobstructed arm mobility when using the side stick or tiller. There's a small step near the inside shoulder of each seat back for access to an overhead escape hatch. A compartment holds an emergency rope that flight deck crew can use to slide down the side of the plane. Side stick. A side stick controller on each side gives the pilot or co-pilot control over the roll and pitch of the aircraft. An autopilot priority switch disconnects autopilot if it's engaged. With autopilot off, holding the button gives this side stick priority. A pitch trim switch can set the auto trim rate for the horizontal stabilizer or allow manual trim adjustment in direct mode. There's a switch at the front of the stick for radio or intercom communication. Steering. While taxiing under 30 knots, a steering tiller can be used to turn the nose landing gear up to 80 degrees in either direction. In order to avoid damage to the nose landing gear, rotation is limited from 80 degrees down to 9 degrees max as speed increases from 30 to 100 knots and above. Rudder pedals can be used at any time to rotate the nose landing gear, but are limited to the maximum 9 degrees. In the past, the flight bag at each seating position held airplane-specific operation manuals, navigation charts, checklists, and so on. Electronic tablet devices have replaced most of these items in recent years. Some airplanes may also have a head-up display, allowing the pilot or co-pilot to view relevant real-time information like runway alignment, airspeed, altitude, and more. Rudder pedals. With feet in the lower position, rudder pedals move forward and back for rudder control. Moving feet to the upper position allows pedals to rotate, engaging left and right main landing gear brakes. A mechanical linkage ensures the pedals on both sides move together. Pilots can adjust the pedal position with a knob at the front. Control panels. Now, let's have a look at the control panels, starting with the overhead panel. Many of the switches in these panels have lights that convey important info. something like the warning lights in a car's dashboard. However, unlike simple car warning lights, when pilots interact with these switches, their lighting status can update. A fire module sits in the center. The switches glow red when a fire is detected. Some of these switches are protected with doors that must be flipped open for access. Pressing a fire switch helps mitigate fire spread and damage by shutting off fuel to the respective engine and arming fire extinguisher bottles, among other things. Once armed, nearby switches discharge specific fire extinguishing bottles when pressed. Let's move to the left outboard module. Starting at the back, the entrance knob and dome switch control flight deck lighting. The protected aural warn switch allows the audible warning system to be silenced if there's an issue with the aural system. This system handles the many warning sounds and phrases that alert pilots to critical events. Window heat and probe heat toggle the icing functionality for windows and external temperature measuring devices or probes. Primary flight control computers can be individually disabled using any of these three protected switches. The CVR section handles the cockpit voice recorder, which records not only sounds inside the flight deck, but also all connected audio channels, both internal and external. The next panel section has knobs to control lighting brightness for circuit breaker panels, overhead panels, the compass, and more. Turning this knob to the storm setting illuminates the complete flight deck, all panels and dome lights to maximum intensity. The next panel controls communication during plane servicing. With the service intercom switch on, all flight deck and service intercom channels are opened. The call button sounds a horn in the external service panel area. At the end of this module, there are captain's side reading light and windshield wiper controls. Now let's move to the left inboard module. The hydraulic section has controls for various hydraulic system scenarios, since there are 3 separate hydraulic systems in the plane for safety and redundancy. This panel allows various configurations so these systems can work as normal or supplement each other in varying conditions. The electrical section has a knob for various electrical system scenarios. For example, the ESS setting powers only essential systems. The guarded switch next to this knob turns off power to select cabin systems, which can be useful for isolating sources of smoke in the cabin, whether from electrical arcing or some other source. The guarded RAT switch allows flight crew to manually deploy the ram air turbine, or RAT. Under normal conditions, the RAT will deploy automatically if power is lost in flight. Battery knobs control onboard battery packs 1 and 2. The left and right gen switches toggle engine-driven electrical power generators. Each has a protected disconnect switch to disconnect the generator shaft from the engine if, for example, leaving a malfunctioning generator connected could lead to engine damage. The APU switch can disconnect the auxiliary power unit from the system in case of an electrical fault. The EXT switch allows crew to toggle the external power connection. The APU pull-turn switch functions something like a car ignition. The start setting is held for 3 seconds to start the APU. Once started, the switch reverts to the run position. The APU fail light illuminates for any electrical, fire, or starting issues. The terrain awareness and warning system has protected switches to turn off aural warnings associated with landing gear, terrain detection, and flaps. The GS switch turns off aural warnings related to glide slope, which is the pre-calculated path of descent in the flight control system. Moving to the right inboard module, we see the fuel subsection. With the manual transfer switch in off mode, the fuel system functions as normal. The other settings allow flight crew to select specific fuel tank configurations. Left and right boost pump switches control supplemental, electrically powered fuel pumps, where the system under normal operation relies on engine-driven pumps as the primary source of fuel pressure. The gravity transfer switch opens valves so that the fuel can move between tanks by gravity alone. The air section has climate controls at the top, and also ventilation settings for cargo compartments. The trim air switch toggles valves that allow air from the engine bleed air system into the climate control system. When the pack flow switch is active, the air conditioning units, or packs, enter high flow mode, which can be useful for clearing smoke or odors. There's a switch for recirculating air fans. The guarded ram air switch can open external ports at low altitude for flight deck or cabin ventilation. Left and right pack switches grant manual control over air conditioning packs, which otherwise operate automatically based on desired climate control settings. Cross bleed, left, and right bleed switches grant manual control for engine bleed air valves and APU bleed air. The anti-ice section controls de-icing capabilities in the left and right engine cowling and wings. Right overhead module. The ELT, or Emergency Locator Transmitter, pull-turn knob can test and arm the ELT. The cargo section handles fire reporting and deploying fire extinguishing bottles in the cargo areas. Equipment cooling refers to cooling systems for equipment bays. The inlet switch controls cooling fans and an external valve to take in outside air. There's also a switch for exhaust air produced by the equipment cooling system. In the pressurization section, there's a guarded switch for emergency depressurization of passenger and flight crew areas. The auto press switch allows manual pressurization control, which is usually an automated process. In manual mode, the dial beneath sets the pressurization rate. The guarded ditching switch activates a ditching sequence. Ditching is a controlled emergency water landing in an aircraft not designed for such. The ditching sequence closes all valves below the aircraft flotation line, except for the ram air valve. The pack's oxy switch deploys passenger oxygen masks. At the end of this section, there's a switch to toggle the evacuation horn, and a pull-turn switch for evacuation lighting. Beyond that, we see the co-pilot side windshield wiper and reading light switches. Lights overhead module. Starting from the pilot side, there are external lighting control switches for navigation, beacon, strobe, and logo lights. The landing light section has a taxi light switch and special switches with triple LED indicators for left, right, and nose landing gear lights. A pair of switches in the pack's lights section control the seat belt and no personal electronic devices warning signs in the passenger cabin.